Hello everybody, welcome to Waves Lesson 6. This lesson is about radio waves, microwaves and infrared radiation and their uses. For this lesson you will need a pen or a pencil, a piece of paper or something to write on, and if you want to you can use a calculator. If you don't have those things, go and get them now, pause the video, press play when you're ready to begin. We start this lesson as we always do with a little mini test. 2 parts to it today. Have a look at the questions, write down your answers, pause your video and we'll go through the answers in a moment. Let's see how you got on. What is a transverse wave? Well, it's where the vibration or disturbance is perpendicular or at right angles to the direction of the wave or energy. What is a longitudinal wave? It's when the vibration or disturbance is parallel with the direction of the wave or energy. What is the wave equation? It's V equals F lambda, or the velocity is frequency times wavelength. Draw 2 diagrams to show the difference between a low and high frequency wave at the same volume. It's going to be something like this. You can tell because they both go the same height, but they're the same volume. But this is the low frequency wave on the left and the high frequency wave on the right. And how can you make a higher pitch sound? Well, whatever's making the sound, you get it to increase its speed of vibration, get to vibrate backwards and forwards quicker. You remember we did that with the elastic bands and the rulers, etc. You got all those right? Well done. Let's move on to mini test part B. Write down the answers, pause your video. What is the law of reflection? Quite simply, where the angle of incidence, remember that's the one that's going into the mirror, equals the angle of reflection. That's the angle coming out of the mirror. You might have also mentioned you measure it against the normal, the 90-degree line. What do we call it when a wave changes direction as it goes into a different density substance? We call that refraction. What do we call it when waves go through a gap about the size of the wavelength and spread out? We call that diffraction. What is TIR? TIR stands for total internal reflection. Remember, that's when the angle is too big, when refraction is normally taking place when the angle is too big to escape. You got those right? Well done. We're going to start this lesson by drawing a table to record lots of information about electromagnetic waves. You'll need to copy this table down onto your piece of paper or into your book. Make sure it's nice and big, use a ruler, and you can fill in all these bits and pieces that are already there. As we go through the next couple of lessons, we'll fill in all the remaining empty boxes. So, pause the video, jot down the table, and then press play when you're ready to begin. Okay, so last lesson we did some work on light. We've already filled that in on our table. What we're going to look at next is radio waves. Here is a map of the south coast of the United Kingdom. In particular, this bit of map is showing the Isle of Wight. Why are we showing a map of the Isle of Wight? Well, on the Isle of Wight, somewhere around the end of that arrow, is a TV and radio transmitter at a place called Rowridge. And Rowridge has a transmitter that transmits radio and TV signals all across the south. As you can imagine, it's going to be on the top of the hill. Nice big tall mast there, so it doesn't have too many hills in the way to stop the signal. The useful thing about radio waves is they have a longer wavelength, making it easier to reflect off hills, and in particular, the upper atmosphere. And these are a couple of things that might receive radio waves: television and radio. Those things will need recording into your table that you drew just a little while ago. So all the new stuff I've put on is in red. So you need to add that to your table now, pause the video, and then we'll move on to microwaves in a moment. So there are 2 things that use microwaves, albeit they're not at the same frequency. You've got a mobile phone, which is a very, very, very low powered device. A typical mobile phone these days will produce less than 1 watt worth of power. Very, very, very low power compared to a very high power microwave oven, which is sort of 750 to 1,000 times more energy produced by it. So, and they're not interchangeable. You can't get a mobile phone, stick it next to a potato and cook it by phoning your friend or chatting for half an hour or something like that. It doesn't work that way. They're not identical frequencies, not identical wavelengths. And of course, a mobile phone is very, very, very low on power. So how do microwave ovens actually work? Well, the microwaves that are produced by the oven are exactly the right wavelength and frequency to excite water molecules. So you can only cook things in a microwave oven if there's some kind of water content. Some food is totally dry and the microwave oven will not heat it, but it heats up the water. The water molecules get very, very hot. Now, it's not direct radiation heat like you would get in an oven. It's actually just the water molecules get excited by the wavelengths. And the water molecules get hot and the water molecules cook the food basically from the inside. We're going to add microwaves to our table now. So dig your table out. Again, the new stuff I've written in red. Pause the video. Okay, the next type of energy we're going to look at is infrared energy or infrared radiation. Infrared radiation is basically heat. You feel it is heat when it's in high quantities. It can be detected by electronic devices in very low quantities. Remote control, a lot of traditional remote controls, maybe not your fancy Bluetooth ones these days, but your remote controls traditionally all used to use infrared signals. They cannot travel through people very well, so if you stand in the way, the remote control really doesn't work. Just give you a little demonstration here. So we hit the on button on the remote control, little signal, infrared signal is sent up to, in this case, the projector, and the projector turns on. And that's how infrared remote controls have worked for many, many, many years. Another example of infrared radiation now, this time it's a thermal imaging camera. And a thermal imaging camera is very good at picking up quite low levels of infrared radiation.
Spotted tonking it up the M55 in Lancashire is this criminal in a stolen car. First, he thinks he can outrun the police, but very few cars are fast enough to get away from such a posse of cops on an uncrowded motorway. And in any case, he seems to have forgotten the chopper shadowing his every move from the air. Perhaps the police drivers won't be able to follow him as he carves across an open field. It's been raining heavily and a chopper's thermal imaging camera shows up the mad driving as if it's some old-fashioned waltz. Narrowly missing the lamppost, he finally regains the road, but fails to regain his senses as he continues to try and outrun the cops. Finally realising he's been trapped by the chopper, the car thief's few brain cells kick into gear and he heads for the nearest trees, thinking it'll give him enough cover to hide. But he fails to notice some key points. First, it's only a few trees, not a big forest. Second, he can be seen using the thermal camera. And finally, he's completely surrounded.
That's number 2 on, it looks like one arrested.
There's no chance of a last stand and he's quickly wrestled to the ground and charged with nicking the motor.
There we go, the police thermal imaging camera. You can see that the hotter something is, the whiter it shows up on the thermal imaging camera, the whiter it glows. I did hear the story of the police using their thermal imaging camera. They've been out on some police chase somewhere, and as they were flying back, they flew over some housing estate, and they had the thermal imaging camera on, so I've got to switch it off. And they noticed a roof of one of the houses was glowing really, really brightly white. They thought, well, that's a bit odd. Must be very warm in that loft. So they sent the drug squad around about a week later, and they found a cannabis factory in the roof. So it can be used for lots of different things. Thermal imaging cameras can be used in rescues. For example, in an earthquake, thermal imaging cameras can be pointed at the rubble and sort of half fallen down bits of building. If there's someone in there, they're giving out just a little bit more heat than the surroundings. So it's going to show up white on the thermal imaging camera against the slightly colder surroundings, and it makes them easier to locate bodies. At the other end of the extreme, if there is a fire and the fire brigade are there trying to put the fire out, they can point their thermal imaging camera at the hot fire. But obviously, the bit where the fire started is probably going to be even hotter than the actual flames, which are relatively cold. And that will show up brighter on the thermal imaging camera, and it will tell them where to direct the water to get the fire out the quickest. So let's add the infrared radiation to our table, shown up in red here. Add that to the table, pause the video. Well, that's nearly it for today. We're going to finish off like we always do with a little mini test. Write down your answers, pause the video, and we'll see how you've done in a moment. So let's see how you've got on. What do the long waves of radio make it easy to do? Well, it makes it easier to reflect off hills and the upper atmosphere, which ultimately means the radio signals can go further. How do microwave ovens work? Well, they excite the water particles in whatever they're heating, which get hot, and that's how the food gets cooked. How is infrared radiation felt in your skin? It's felt as heat. You feel it quite hot when your skin picks up infrared radiation. Name 3 places thermal imaging cameras might be used. Well, the 3 from the lesson are the police helicopter, looking for bodies in earthquakes, and finding the seat of a fire. If you got them right, well done. If there's anything you're not sure of, feel free to rewind the video and have another look. Otherwise, that's all, folks. Thank you very much.